Hey everyone, this video we're going to be looking through our first quiz for energy. So in my first question here, we're looking at Surfer Bob making some popcorn, and he's using electricity that's produced from a hydroelectric generating station. So we have to figure out what are the energy transformations for a hydroelectric generating station. So this is right from your notes, but I do want to review it with you. So at the beginning, what's happening is you're going to have water that's at a height above the turbine. So it's quite high, and because of that, difference in height, you're going to have gravitational potential energy. Sometimes the water is also moving, so this EK could be optional, but you definitely have gravitational potential energy. The water then falls, so we're going to have EK, energy transformation. And once it falls, it begins to spin this turbine down here. And when the turbine spins, that's again another form of kinetic energy. So we're going from EK to EK, just changing the type of motion. And then finally, the turbine is hooked up to a generator, and the generator is going to be making electricity. So those would be my energy transformations. So be EG to EK to EK to electrical energy. And you should indicate above each of the arrows for the energy transformation what is kind of happening for every single step there. All right, part two. What's happening in the microwave? Well, in the microwave, you're going to have something called a magnetron, and what it makes is microwave. So it takes electrical energy, so the microwave is plugged in, and the magnetron makes microwaves, so it's going to be making a form of radiant energy. Remember, radiant energy is any kind of electromagnetic energy. And then the radiant energy, the microwaves, are going to cause the water particles to vibrate, which creates thermal energy. So the energy transformation here would be electrical to radiant, and finally to thermal. You can ignore the rotational spinning motion of the food. Don't worry about that. And also don't worry about the sound or even the light that's inside. Focus on the heating of the food for this particular question. All right, let's go on to the calculation. Now the calculation here, we've got an elevator, and the elevator is traveling from the first floor to the second floor. It takes 2.9 seconds to go up. It tells us that we have a mass over here, and the power rating is 21 kilowatts. We can't use kilowatts. We're going to convert it to watts. So 21,000 watts. Now, what's happening here is I got an energy change, and I also have power. We know that power is equal to the change in energy over time. Well, what kind of energy do we have here? We are lifting something up. We have a height. That means we've got gravitational potential energy. So you can do two calculations. You can determine the power energy change and then determine the height. I'll do things all in one step. So I'm going to substitute the EG, MGH equation into the power one. So it'll be power equals MGH over change of time. Bring the time over here, substitute all my values, and then simply solve for H. And when I solve for height, we're going to get a height of 3.167 meters. Wait a second, how many significant digits? We skim through here, looks like 2 significant digits. So therefore, the elevator is going to be 3.2 meters above the ground after traveling for 2.9 seconds. That's it.